Lesson 5 is on limits of transcendental functions. So what exactly is a transcendental function? So if you look it up, and I looked it up on Wolfram's Math World, it is a function that is not an algebraic function. In other words, it's a function which transcends, which can't be expressed in regular algebraic terms. You guys have dealt with a lot of these over the years, our exponential functions, our trig functions, and the inverse of both of these. So that's going to be our inverse trig functions and also our log functions. So we're going to start by doing an example by connecting multiple representations of limits. Let's start with exponential functions. Exponential equations are written in the form of y equals ab to the x minus h plus k. And you have to find limits of exponential functions, and many times, because these are such a common function, they're in the non-calculator section. So the thing is, you have to remember your transformation rules to make this easier. And it's going to, whether it's an increasing or decreasing function, whether you're going to an asymptote or to negative or positive infinity, is going to depend on knowing the rules and understanding how the reflections look. So let's start by doing some examples from the graph and moving on from there. So letters A and B, we have f of x is equal to 3/2 raised to the x minus 1 power minus 3, and the graph is right there. So the question is asking us, what is the limit as x approaches negative infinity of f of x? So that is going to be down this way, and it's skirting along that horizontal asymptote, so the value of the limit will be -3. And then as we go towards positive infinity, what we see is that the function is unbounded, so we are headed towards positive infinity. So that was a growth function. And how we know it's a growth function is because the number raised to the power is a number larger than 1. So in letter B, what we have is a decay function. The number raised to the power is between 0 and 1, so we have a decay function. Okay, so let's do the two limits that are listed here. So the limit as x approaches negative infinity, so we're headed this way, and we see that the value of the function is unbounded, so the limit will be infinity. And then as we're headed towards positive infinity, we're going down this way, and we're skirting again along that horizontal asymptote, so that's going to be -3. Okay, the next two. C is dealing with our natural base E. So now we have a reflection because we have a negative sign in front of the E. So we're looking first for the limit as x approaches negative infinity. So that would be this way. And again, we're headed up to that horizontal asymptote, which is 2. And then the limit as x approaches positive infinity, so we're headed down this way. It's going to be -infinity. And the next one is going to be -1/2 raised to the x plus 3 power plus 2. So again, we have a horizontal asymptote of 2. So as x approaches negative infinity, the values of the function are also headed towards negative infinity. And then as x is approaching infinity, we're up along that horizontal asymptote again of 2. So the one thing I didn't put is that letter C is a decay function because of this. And letter D is a growth function. Now you might say, that goes against what we learned because E is greater than 1 and 1/2 is less than 1. So normally when you have a base that's between 0 and 1, you have decay, and when you have a base greater than 1, you have growth. But it comes down to the reflections. So we're going to talk about that in a little more detail. So using the graphs that we just had, we're going to summarize our growth and decays. And we're going to talk about how the reflections play into that. So the first example, letter A, this was a growth function. And it had no reflections, but our base B was greater than 1. And so what we noticed is that as we headed towards positive infinity, we were headed towards the horizontal asymptote, which was -3. And as we headed towards positive infinity, we had an unbounded function, because that's what the growth implies. Okay, then for letter B, we had a decay function, and our B was between 0 and 1. And again, there was no negative signs, so we had no reflections. And so being decay, it was started out at a huge value and works itself down to its final values. So it was unbounded on that side. And then on the positive infinity, it headed towards the horizontal asymptote again. So it's going to be -3. As I mentioned earlier with the E function, this should be a growth function, but it turned out to be a decay function. Even though our B was greater than 1, the problem is our A is less than 0. So that means that we had a reflection. We had one reflection, which is right here. That's our A. Okay? So that flips it upside down and makes it a decay function. So that switches the order. So it's going to follow the decay idea, that at the limit as x approaches -infinity is going to be 2, but since it's decaying as x approaches infinity, we're going to get even smaller and smaller values, so we're headed to -infinity. And now the last example turns out to be, instead of decay, turns out to be growth. And the reason for that is, yes, B is between 0 and 1, but A is a negative number. That's supposed to be a less than symbol. We get one reflection. So that's going to take our decay, it's going to flip it over, and it gives us the opposite of what we'd expect. So as we head towards -infinity, we are coming from very, very small numbers, and they're growing, and it hits the ceiling of the horizontal asymptote of 2. Okay, so that's what you have to keep in mind when you're looking at those on the exam. So we have 3 cases, and here's our 3 cases that we're looking at. The end behavior of any function, you have 3 choices for an exponential function. It could be -infinity, it could be positive infinity, or it could be y equals b, the horizontal asymptote. And I'm not being specific about which end, because it just depends if it's growth or decay, whether you're going to be headed towards positive infinity or negative infinity, because end behavior happens at both very large x's and very small x's. So let's summarize what I was saying about the growth and decay. So based on the value of b and whether a and x are negative, I didn't give you any x's that were negative yet. Here's what's happening. If b is between 0 and 1, and you want a growth function, which normally would be a decay, what you have to have is it has to be reflected once. So you're taking a function that normally looks like this, and you're flipping it over like that. So it's growing, so the end behaviors are flipped. So if b is greater than 1, whoops, I said 1, then I write 0. If b is greater than 1, you can have no reflections, or 2. You could flip it over to be decay and then flip it over again. So in that case, what you have that a is less than 0 and x is negative. So that'll give you a reflection over the x and the y. So you're back to having a growth function. It won't look exactly the same as it did, but the end behavior still reflects growth. For a decay function, it decays the normal way that we learned in Algebra 1 when b is between 0 and 1 and we have no reflections. So a is a positive number and you have no negative x. And then if you have a b that's greater than 1, like e, that happens to turn into a decay when you have one reflection, not both of them. Okay, so let's work this out without a calculator. So for letter A, we want the end behavior in the negative x direction, so for very, very small x's, of negative 0.3x plus 2. So if you want to make a quick little sketch, you can. It might be helpful. What I see is, before I start, I see that my A is equal to negative 1, my B is 0.3, okay, and my x is positive. So what I have here is I have one reflection. Okay, so sketching this, here's what I normally do. I'll just throw a sketch here, put where the horizontal asymptote will be. It'll be at 2. And then I'll put what the normal function would look like. So normally it would be decaying. It would look like this. But it's been reflected, so it is going to look like this. So that tells me that the limit as x approaches negative infinity of my function, I'm just going to call it f of x for space, is going to equal negative infinity because we have growth here. So as we're headed this way, the values of y are getting smaller and smaller. Okay, so for the next one, what we see is that we have a horizontal asymptote again of negative 3. We now have a negative x, so we do have one reflection. So let's go ahead and sketch this. So we know our a is e, and we know our x is a negative x, and I'm sorry, that's our b. Our b is e, and our a is positive 1. So we have the one reflection. So here's where the reflection happens. Okay, so sketching this real quick. So normally it would look like this. Here's my negative 3. And normally it would be a growth that would be like this. But it's been reflected over the x, so it's going to go in the opposite direction. So it's going to go this way. Because the reflection is about that, so it's reflected over the y. I think I said that wrong. The reflection comes from the negative x, but it's reflected over the y. I think I said that the first time. I said it backwards. So we actually have decay here. And so as the limit as x approaches negative infinity, we'll call this g of x, what we see is that it is growing here. So it's headed towards positive infinity because we have one reflection, which is in our table. Okay, I'm going to do two more with you, and then you guys can do the last two on your own. And I will put the limits up. Actually, I think I'll do all four of these. That's fine. I'll just do all four of these. Okay, so the next one, we're looking for the positive end behavior. And in this one, what we want to notice is we have two reflections. It's reflected over the x-axis and reflected over the y-axis. And we want to do them in the right order based on order of operations. So the graph, which normally, here's my asymptote, which would normally look like this, is going to first be reflected over the x-axis. So it'll look like, reflected over the y-axis because we take care of that reflection first. So it would look like this. But then we have to flip that over because of the other one. So our final graph is going to be like this. There's our final graph. Because we're going to take that orange dotted line and flip it, and it ends up looking like that. So what we end up with is two reflections. So we took something that was growth, we flipped it over to make it decay here, and then we flip it again, and it ends up being growth. Okay, so that's how that works. So the limit as x approaches positive infinity, I'm going to call this h of x, is going to be -3, our horizontal asymptote. Okay, we have one more of those. And now again, we have two reflections, one over the y-axis and one over the x-axis. And again, we'll do the one over the y-axis first. So in this case, make note to the fact that normally b is 1/3, which is less than 1. So normally we would have decay, but we're going to flip it to make it growth and then flip it again to make it decay. So the final shape of this is going to give us decay. So that would mean I can say right now with certainty that our limit is going to equal negative infinity. But let's go ahead and sketch it. So we have a horizontal asymptote of 1. So normally, as I said, our graph would look like this, like that, but we're going to reflect it over the y-axis, so it'll look like this, and then we'll reflect that again. We're going to flip it upside down, so the final graph will look like this. Whoops, I drew that too far, right into the other one. Okay, so like that. So again, we have two reflections. So we went from the original decay to growth and back to decay. So we get our limit of being negative infinity. Now you want to understand that all of that deals with end behavior. If you're just dealing with specific x values, such as in E and F, you can try direct substitution. That should work. So for letter E, I want to take the limit as x approaches 2. So I'm going to substitute 2 in for x. And what I get is e to the -1 minus 1. So this becomes 1 over e minus 1. And making one nice fraction, I end up with 1 minus e over e. And same thing for the next one. I can substitute -3 in. And so I get 1/2 to the 3 minus 1 because I have the double negative there. So I get 1/2 squared plus 5. So I get 1/4 plus 5. And when I make that a single fraction, I get 21/4. I'm going to stop this video here and pick up our discussion in the next video.